Okay, we're now coming to my favorite part of the day, because I loved all your talks already, but I like them even more if they're just 5 minutes and less slides. So now we're starting with the lightning talk session, and since lightning talks are only 5 minutes, I'm always telling you who's doing the next talk and then the talk after, so that person can please also get ready. We're starting with Enric, who will also give the keynote later, so I put him in the first spot so he can relax for a bit after that. And Enric is talking about how to create art installations with Snap. And then after Enric, we have Joek sharing his thoughts on mathematics and computer science. And we'll also always put a timer here, so we've got 5 minutes. And please try to stick to that time, because again, I didn't schedule any breaks. Sorry for that.
Thank you. Thank you. I'm Enric. I will talk about just 5 minutes about creating art installations with Snap. So what is an art installation or an interactive art installation? Is a form of digital art that requires, I highlighted the important keywords, so it requires participation from the public or the audience. It uses interfaces that sometimes, I mean, the interfaces are always there, but sometimes are forgotten. It requires interaction from the audience, and it's an artistic experience. And the viewer is the central part, even though the artists that build interactive installations think that what they build is the central part, right? It looked like that. This is an interactive installation that the audience just turns some knobs. It looks like that as well. These are photos from the ICLC, the International Conference on Live Coding, that we organize in Barcelona at May. It looks like that. That is an installation, but it's not an interactive installation because it's a LED panel that just show some messages. Some of you, I mean, the ones of you that were at Robolot were able to see that. So the keywords for the interactive installations that they are experiential, participatory, embodied, so it requires the way the audience interact usually requires the whole body. There's always an interface, and it happens, it develops in real time. And there are other kinds of installations. These are really big format installations, but I would like to show you. These are from the Mira Festival in Barcelona last November. Another installation, this is a building that has a staircase or a big hall like the building we are right now. So there is a lasers that were projecting and synchronized with the music. Those were not interactive installations, right? Really big installation, not interactive, but digital, computational, etc. These were interactive, so some lasers and some light bulbs that were going down and up, so the people, I mean, it was like you were inside water or whatever and floating away, so that was really nice. You could see the cables with the light bulbs. And then this is an installation from the Sonar Festival last June, also in Barcelona. This is a more standard installation, like someone that you go closer and do things with it. Right, so I'm going back to the presentation. I only have 2 minutes. So a book recommendation for you, A Touch of Code, that is a compilation of installations. So I go directly to the Embodied Code Interactive Likeness. That is an installation that we propose also for the International Conference on Live Coding. We is Bernat and other people from my research group. We wanted to be exploratory in terms of, for us, building that installation was like a research object, it was the research study. So we wanted to learn how people interact with artifacts. We wanted them to be reflective about code, to be playful, to be educational, they learn code, and also be collaborative. And we have 3 levels of interaction that were embodied parameters, so people go there with the their body, as we all go, and then interact with the installation. Then they could interact with the mouse, and then within some parameters, and later, like the 3 level, they have completely freedom to even destroy the script. So that was the initial scheme. So that's working with the installation, with Bernat, the first prototype. So the installation is MicroBlocks with that produce music and Snap that produce visuals. So the goal, since it was the live coding conference, was to show the code that was running the installation and people to be able to interact. There you can touch the screen, right? So here you can see some keyboard, some mouses, so people were allowed to change things. Here was Bernat giving explanations about the installation, and that was the first version of the installation built with Snap and MicroBlocks, and the final installation I will show you later in the keynote. Thank you. No, you already have a mic.
Okay, next up is Joek, and then Ursula, you can get ready online too, because you're the next one after Joek.
I have this one, okay. Yes, I can have this one. Yesterday on the train to Heidelberg, my laptop was stolen. So if I had preparations, they would have been in the laptop. So I'm happy I have an old school recording system. And I made some notes. I'm here just to rant a little bit about computer science education and math education, and tell you something about how I hope we will get out of this. I'm trained as a mathematician. When I started studying in '81, mathematics was still a subject that had to be taken together with physics and computer science. I immediately dropped out. I switched to philosophy, but the next year I started again, and that was totally different, because then it was possible to study mathematics without physics and computer science. And I decided I only want to study mathematics, higher mathematics, without practical applications. 6 years later, I dropped out again, because that's not the right motivation to study mathematics. There is no such thing as mathematics without applications. It's only that some applications are not known yet. And 20 years later, I dropped out from corporate. I worked at the Dutch railroads, and I started over, and quite soon I tried to do my children were going to school, and primary school, and all of a sudden there were computers, and nobody had a clue what to do with the computers. And I thought maybe I can make myself good to help them do creative things with the computer. And that took me a while. It get off a little when I encountered Scratch, but still, I failed introducing computer science as a primary school subject. They now know that Scratch exists, but it's not really a subject. In Holland, computer science is an elective, only possible for children age 15 till 18 years, so the last 3 years of high school. And it's an elective, which means that a lot of schools don't offer it, and the schools offering it in the Netherlands are shrinking because there are no teachers. And this also just happened to me. Last March, my principal told me that the school was getting smaller and we couldn't offer all the electives anymore, and they kicked me out. Well, they said, you have 4 years time to do the last kids, and we will kick you out after 4 years, unless you want to stay with us and solve another problem, teach mathematics. So, and why they choose to kick out computer science? Because we are so-called creativity school, and we have drama, so theater making, and we have drawing as a serious subject, an exam, that subject. And computer science was regarded not so creative. They don't know, but because they don't have time to look at my lessons, I think computer science in the Netherlands, especially at the Montessori Lyceum Amsterdam, where I teach with Snap and TurtleStitch, etc., is very creative, but okay. And now my rant. The rant is, I have just a minute for this, and I think it's the same everywhere. Mathematics is taught in the world for thousands of years, and they have a strong idea about what they want to teach, and they're quite happy with it. And mathematics teachers are not seduced to change their subject. And I think with computer science, we have so much overlap. It wouldn't be a problem to teach computer science as math 3 or math 4, or a different kind of mathematics. We have the same ideas about arranging knowledge, and I have only 10 seconds left. And I promise you that I would end with that this is about TurtleStitch, and it kind of is. I want to revive the idea of Peppered, that we can, we as computer science of teachers with TurtleStitch can offer a math land to people who have difficulty with TurtleStitch. 1 month ago, we had a big event on TurtleStitch. You will hear more about it tomorrow. And a lot of things happened there. And there's a tiny thing what happened. And that's that my wife came. My wife is psychotherapist, or totally other field. She's 59 years old. And she went, programming a flower with 5 leaves, petals. And it was, she was helped by one of the TurtleStitchers, and it was the first moment in her life that she had the feeling that she understood angles and degrees. So yes, we computer scientists can help the math teachers, and if they don't want to offer computer science courses, we maybe should offer math courses disguised as computer science courses disguised as math lessons. Thank you.
Talk is by Ursula online, sorry. And afterwards, Gerd and Volker, can you please get ready? Ursula, you're good to go.
Okay, I am trying to share my screen. I don't think I am successful.
No, works. We can see your screen. Works.
That's not the right screen. I was trying to go for a particular window.
Yeah.
I'm sorry to waste the time on that.
That is okay.
Well, let me see if I can get this. Oh, there we go. Yes? Yep. Do we have a slideshow?
Yeah, we have a slideshow. Yeah.
Okay. This is about code in the bag, and it follows directly in what Joek was saying, because a lot of this was also influenced by the TurtleStitch people. Code in the bag is a repository for creating with rather than consuming computing. Alternatively, it's how I spent my summer. 50 years ago, Seymour Papert introduced me to powerful ideas at MIT. Microworlds and how computer models facilitate authentic learning across domains, what Joek was talking about. Computer-based microworlds led to the notion that algorithms and data were powerful ideas in their own right. Seymour assumed that microworlds must include authentic human interaction. But the details of how to facilitate such interaction, in the words of mathematics professors, was left as an exercise to the reader. I've been struggling with those exercises for a long time. Inspired by TurtleStitch, Code in the Bag is a repository for creating learning modules for both fiber arts and computation. It emerged from a decade of teaching coding via fiber arts to craft enthusiasts who are math aversive. Through human-curated, handcrafted activities, students embrace computational concepts. They discover that fiber artists have articulated, passed on, and improved upon the powerful ideas in computer science for millennia. They learn to appreciate that mastery requires patient practice, preferably through their own creative products, namely beautiful things. Code in the Bag is a wordplay suggesting it's easy to learn the culture of craft as you create your own bag of techniques. Making a physical bag in its multiple forms and embellishments is an implementation of an abstract algorithm employing specific data, like TurtleStitch. The algorithm, called a pattern in crafting culture, describes how to, sound familiar logoites, to create the artifact. The process has component parts, requires repetitions, selecting among alternatives, handling exceptions, and operating on data. The Code in the Bag repository proved its worth March 6, 2025, when on 2 weeks' notice, we ran a How Math is Used in Quilting exhibit at Community Math Night in Bennington, Vermont. See the quilt in the upper left-hand corner. Attendees contributed a block to a collaborative quilt by gluing fabric to muslin using a 9-patch pattern. The quilt will be exhibited in a couple of weeks here in Bennington at a quilt fest. In spring 2025, the repository was used to create 3 90-minute craft tastings, no, not peer, held in July and August for the Bennington Free Library. Foundational concepts of crochet, embroidery, and quilting were introduced to 3rd and 6th graders and some adults. Experienced fiber artists mentored highly individualized product production, while the process was quietly related to computation through conversations. On September 6th, next week, for 4 hours, the same mentors will offer 6 stations to produce a more elaborate quilt at the Bennington Museum open house event. Visitors can browse, sample, or spend leisurely time at mentored stations. In the coming academic year, we will be offering crafting circles at community centers and multi-day in-class and after-school activities to support school district math curricula. We couldn't do it without the repository. Code in the Bag is a multi-dimensional, multimedia catalog of activities to customize microworlds. Building it and using it requires human domain expertise to sort through the overwhelming, sometimes conflicting, sometimes hallucinated resources on the internet that also often include inappropriate commercials. The repository is a network of instructional snippets, each of which produces a simple artifact. An activity designed for a specific purpose is a tree of snippets. Snippets include links to related snippets in other domains, potential problems, historical background, and of course, prerequisite skills. The repository is being built by hand, intentionally, using traditional AI search and logic to navigate a dynamic knowledge structure. Expert human engagement is essential to the activity. This became clear in our embroidery tasting. A hand-embroidered activity was successful because it was carefully planned by experts, supporting gentle, individualized conversations about embroidery and computation. All of the participants grasped that embroidery involves materials, data, a general instruction sequence, algorithm, and an implementation process that may require debugging. TurtleStitch, unfortunately, had a less positive outcome because we did not anticipate the inexperience of the participants or that the unreliability of embroidery machines should be assumed. Rather than engaging in conversations with each other, everyone struggled to control the machines. The powerful ideas were lost on everyone. We are debugging that activity. Code in the Bag facilitates the design and execution of learning environments in which powerful ideas can emerge and evolve for everyone. Please join us by emailing me. Thank you.
Thanks, Ursula. Next up, we have Gerd and Volker, and after that, Bernat. I think will play some music for us.
Welcome to CodePainter at Snap. And now we are going back to the basics. The story of CodePainter at Snap is really a story about a girl and a boy in the starting. Huh? And we were giving a session about Snap and art and for beginners, and there was a girl rebuilding all those blocks and the shape that we showed them directly in Snap, and she built paintings by just driving the sprite where she wanted it. Then she was triggering the code, painting the hexagon, and then go to the next step and painting the next hexagon and build a picture on this way. And then a boy said, why don't you use loops and moves and conditions? And then she looked at him, saying with her eyes, what the heck do you want to tell me? And then they sat down and he explained her, and then she understood everything. And that's what the idea when we thought about how to build a tool for very simply help to understand and experience basic elements of coding. And this is what we built CodePainter for. This is why the users should do it, should have it, and this is a first look into CodePainter. It's a type of treasury hunt. You have a map here, and you get somewhere located with a pink point, and then you have to follow to the goal on the right side. You see the Twitter code, and you have to follow it, and you have to go through it by using the arrow keys, up, down, right, and left. Huh? And this is how it works. And it looks this way. You can go, you see on the right side, you see what to do. And this is very simple. Go right, 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 and you see the track is pointed by showing by the black line, and what goes to the right also goes to the left. Go one to the left, and then you will see a bouncing algorithm that it goes back to the other side by the orange side, and so it goes on. What goes up also goes up and down, 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 and it goes all up, 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 up. So that's for warm up, and then you have such such exercises that you can follow. Want somebody to try from you? Somebody else wants to try it out? How it works? Come on. Okay, the next one is a little bit, yes. Okay, see you here, we have the orange bottle included, that you have some kind of differentiation, and that you can also have that as until and if and so on. Huh? Next one. Okay, and those goes on. Something more complex. Here we have another if with a if else. Great. Now a little more complex. Great. This is real complex. Anybody else here wants to try it out? Okay.
Actually, it's kind of fun, but it's challenging.
You want to try once again?
Yeah. So it's up like 3 times. So
3 times.
left,
1.
goes 2 times now, so it's right, down, then it's left. Wait, but that was.
And this is the way it works. And it's built in such a way that you could build your own exercises. You can define the dimension of the map here. And when we have a little look into the coding, everything is behind this table. You define where to start. You have how much points you have in the X direction, how much points you have in the Y direction, and you can define the starting point in the next one, and you can define some position of the orange points, and then you have here, you see here, the arrow keys that you have to hit, and behind it this is the text, and this way you can define all your own explanation if you want. You can make it pseudocode. Also, you can use here, if you want, Java code or Python code, everything you want to know. And we hope that it helps people or little people who start programming to understand those basic constructions as if, then, else, and while, and so on. No?
Really wonderful. Cool. Thanks. Next up, we have Bernat, who told me to tell you that he's not making music, but noise instead. So I apologize in advance that I made you like have false hopes. And then afterwards, we have Louis telling us about how to draw with numbers and make things.
You can see my screen. Okay, so you can already hear the noise. So the talk today is called Build a MicroBlocks Synthesizer and Play it from Snap. The timer is stopped, I don't know if, okay. I'm Bernat Romagosa, I help with Snap development, and I'm also one of the MicroBlocks devs. And MicroBlocks is a language that's very similar to Snap, but it's designed to program microcontrollers, which are like tiny devices that deal with inputs and outputs and signals and stuff like that. So at Snap Corp and MicroBlocks Corp, we practice what we call ODD, or ODD, obsession-driven development. And one of my latest obsessions has been live coding, which is not only coding in real time, but the live coding practice as an artistic practice is to generate music and visuals in real time with code in front of an audience. And more recently, this obsession has veered towards something even nerdier, which is synthesizing sounds on the microcontroller straight away. And that's what I'm going to try to show you today. So say we have a microcontroller that has a pin where you can output an analog value. I'm going to output a random value. Okay, that was slightly louder than I expected. Why is it so loud? Okay. Is this better? Yes? Sorry, so as you see, this is noise. Basically, random values sent straight to the speaker cone, make it vibrate at a random rate. So you get random noise, white noise as we call it. But white noise, you can modulate it, you can do things with it. So if you make it grow, for example, you get something like a hi-hat kind of thing. If you do the other way around, you get a snare kind of sound. If you do an up and down thing, you get sort of waves or wind. And you can also use different things that are not random. Like, let's say I get the microsecond clock. The microsecond clock keeps growing, right? It's how many microseconds have elapsed since we started the program. But if I apply a module operation to it, I'm taking it down to 0 every fixed intervals, right? So what I get is what we call a sawtooth wave, which is called like that because it looks like a sawtooth. And this is what it sounds like. But I can change this number and get different pitches, which means I can make music with this. Okay, so the next obsession, of course, was to put this all together and wrap it into a library, and that library is called, 1 minute, 2 minutes, is called the Analog Synth Library. It's a library that wraps all this stuff together in order to be able to make music live with this stuff, because you don't want to be dealing with microsecond clocks and, you know. So let me show you very simply. We have these gates that output different sorts of wave shapes, in this case a square wave, and I can trigger this gate and see how I set what we call an envelope. An envelope is sort of how are we going to open this gate. So the amplitude is how big the gate is, the attack is how long does it take to open this gate, hold is how long does the door stay open, and release is how long does it take to close the door. If there are any music gigs here, you'll know there are different types of envelope. This is the simplest one. This is the one we're using in MicroBlocks. Okay? But we could also generate our own synths. So here, for example, I'm mixing a bunch of waves. Let me show you how this sounds. Here I'm mixing a sine wave and a square wave. Let me add another one for good measure. This is going to have okay, right? So let me now try in 30 seconds. I'm not going to be able to explain what I'm doing, I'm sorry. I'm going to connect to MicroBlocks from Snap, hopefully. And I'm going to generate a piano, and hopefully I'm playing that synthesizer that I built with Snap. So okay. And with 3 seconds to spare, thank you very much. Not with this version, but yes, you could.
Sorry, can you repeat the question so the people online can hear it too?
Oh yeah, the question was, can you play 2 notes at the same time?
Yeah.
Not with this version that we built here, but you could do it.
Okay, the next we have Luis, and after Luis we have José telling us about voice programming with Snap.
Okay, hello everyone. Okay, well my name is Luis Mayorga, and I've been working the past 8 years designing workshops, tools, and products in the digital fabrication area. One of my needs of work as educational developer are related to find tools and techniques that allows the participants to feel more fluent with digital fabrication techniques. So during these years of researching, I found that the Scratch-like coding language are a very powerful learning tool. Apart from other characteristics, with them you can easily create significant projects, and after some practice, build complex and professional works, I think. Well, that works include digital fabrication drawings, vectors, and three-dimensional models. And even there is a big number of users. I feel there is not enough documentation for promoting these tools in schools and other educational spaces. So as an important part of building this bridge, this connection between digital fabrication and block coding, I built these resources for doing that. Sorry. So I choose to contribute developing block coding instructional activities that will help to unveil the possibilities offered by the combination of technologies, allowing teachers, makers, and independent students to have an introductory guide for this coding language, attending pre-fabrication and experimental techniques on the area of textile design. The first one is 3D printing over textiles or 3D grids, laser cutting for wooden garments or 2D grids, and laser cutting for seamless unions, 2D interlocks. Okay, that was my work. So the activities will be displayed in printable cards with also samples of the results. So, well, basically that's the project that I would like to present. I built this during my Fabricademy course the past year. So, well, I have here the materials that I've been working with, and well, basically I just want to show, well, these exercises. And yeah, I've been in contact with some of you, and I'm getting some feedbacks. So, well, I have made this manual for doing these activities. Now I can say it's only ready the 3D printing over textiles work. So, but yeah, here is the material, and thank you for your attention. And well, I will be sharing this and the community, so you can also test in your labs or your spaces, and yeah, try to build more things with this. Thank you.
So next up we have José, and then after that we have Jadga, who's apparently still coming up with what she wants to talk about. We'll see.
Hello, I'm José from City Lab here in Cornellà near Barcelona. And I want to show a short demo about a mini device that I try to connect to MicroBlocks. Okay, this is the device. It's a voice recognition device that is totally offline and has more than 100 words to learn it. But the idea is also to teach some, some new words, and these words, my idea is to teach some words to program Snap. This is the MicroBlock part. It's simply a program that reads the command ID that the device interprets, like this. Okay. This is a built-in command. Hello robot. Hello robot. Open the door. Open the door. Open the door. Doesn't understand me. Okay, sorry. Open the door. Now. Perfect. I trained it for a series of commands that can introduce some blocks to Snap. Also to show that it's easy to connect MicroBlocks with Snap, as Bernat showed in the last demo. Simply need to import a library that has only 3 blocks, and the main block is this one, connect to MicroBlocks. You need to choose the port. can be connected also by Bluetooth. And I can check that it's connected, okay? And now I can tell some words to Snap to start create the code, okay? Sorry. Okay, let's start. Clear. Let me, clear. Clear, hello robot, sorry. Hello robot. First, we need to recut the device. Clear. Clear. Sorry, I don't started. Connected, okay. Clear. Why is it not working? Pen up. Clear. Is sending the code. Sorry. Sometimes I have some problems. Let's start again. Hello, robot. Sorry. Hello, robot. Clear. Okay. Repeat 8 times. Now it's adding the syntax in list, and after that we will convert to blocks. Go to center, pen down, repeat 45. Right 80, no, move. I have a mistake. Delete last. Perfect. Move 100. Move 100. Right 89. And repeat. Pen up. And now run code. And now it's running the code. I made a mistake, I think, but that is the idea. Okay, you have a list that can I convert in code, and also you can show the code if you want, the blocks, and you can obtain the blocks that that the device recognizes it. Okay, and I think it's all the demo.
Woo! Thanks, José. That was pretty cool. I think that was the coolest application of the passing feature I've seen so far. Okay, so next up is me, and then the last lightning talk is by Gordon, who will talk about his BloxBuddy. So let me allow. Okay. Allow. Okay. Before I was making fun of slides, I should have thought about what I wanted to show, because I brought slides. So I wanted to share how to work with data in TurtleStitch. As you all know, I've been in South Africa because I keep telling everyone about it. But last time I came up with this whole resource about working with data, and we didn't even use it because we had to go back because we had new kids in the workshops and they didn't know the turtle geometry yet. So we kept going back to the basic stuff that we usually start with. So I thought I'm just sharing with you what I came up with. Why do I think this is important? Because data is all around us, and visualizing data is a really important part of anything, understanding data visualizations. I also think it's interesting because you can pick data that you like. It could be something scientific that you care about. It could be something personally meaningful. I'd recommend you use complete data, manageable data. And it could be something that only you and your group know, so it's like a secret message that only you can decipher. How can you get the data? I mean, you all know there are data sets available on the internet, but you can also gather your own data and save it in list form, for example, in TurtleStitch or in Snap. And stuff that works could, for example, be birthdays of everyone in here, your family members' names, whatever. Then I wanted to share with them useful functions with data. We have the higher order functions in Snap and TurtleStitch. So the keep block, for example, lets you filter parts of a list. In this case, I was working with the examples of the provinces in South Africa. So here we filtered the ones that are larger than 130 square kilometers. That's only the Eastern Cape and the Northern Cape. You can transpose tables, you can pick items of a table, you can filter like for columns in a table, either by using the map block or by transposing them and then picking a specific item. You can load other libraries to work with data, like the frequency distribution analysis library. Then you can sort data, you can create frequency distributions. You can do stuff for each element in your data, for each item in your data. So in this case, for example, this is a spirally thing drawn out of the sizes of the provinces in South Africa. So the smallest one, I think, is Gauteng, and then they're getting increasingly bigger. This crazy huge one is the Northern Cape. So there's different ways how you could represent that data, and they're all kind of visually appealing, and I think that's the interesting and fun part about it. You can't clearly see what it is right away, but this is like the provinces in South Africa. Also here, this is an application of math, because this is if I use the size as a radius of the, I've used the value as the radius of a circle, and this is what that looks like. And this is if you do the same thing and you actually calculate the area, and then use that formula. So this is the mathy version, this is the lazy version of it. And then there's different other ways. So you can do this centered. You can do this, as I said before, in like a circular shape. This is if you order them first by size. You can draw them side by side. You can make them in like a sun shape. So there's a lot of different approaches to visualize the same data, and it's if you have one of them, you can quite easily generate all of them, and that's quite nice. Also, you can like in the workshops we're working with the traditional South African patterns. So this is a shwe fabric that I bought, and it's just increasingly sized diamonds. And here I use the same idea, but instead of just increasing the size randomly, those are the different, like the size of each diamond is again the size of the province in that data set. I also did another project with my family. Greetings go out to my mom and dad. So this is our birthdays in the year. So I'm born on the 192nd day of the year. My brother's born on the 295th day of the year. My dad, my mom, this is my grandma. So here, for example, I came up with different ways to visualize our birthdays throughout the year. So this is, for example, if you would do them in a circle with just lines. Hügle is my family name, so I added an H at the end. You could do the same thing with their names. So this is all our names at that position throughout the year. And again, this is kind of mathy because you have to distribute 365 days on 360 degrees. So you have to think about normalizing things a bit and how to distribute them. Then this is the same if we do a circle and then the letters. I think this one was my favorite one because it looks kind of artsy, but this is just the part of the circle that we cover until our birthday. So my grandma's is on January 3rd, so she's just this tiny fraction of the circle. Then this is my birthday, and my mom and dad's birthday is towards the end of the year. So those are their circles, and they all look kind of nice. And I made one for us here too. I'm probably editing this out just out of data protection, but I made a list with all our names. So every participant at the conference is in here. What do you think is the most common first letter of our first names? J. It's J. Yeah. It's actually J by quite a lot. So first we can. So this is what the names variable looks like. I can first split that by. Oh wait, here's a split by line, and then I can split it by comma. Then I can split it by. Oh, then I can flatten it, so I have actually a list of all our names. Then I can split that by letter. Then I can only get the first letter. So those are all the first letters now. And I can do that using the map block over this list. So now I have all our first letters, and now I can analyze this in Snap. You can do this with the length of block that also has a distribution. Here I had to load the frequency distribution library, and as you can see, we have 13 people whose names start with J, followed by I think M as the second most frequent. So J is definitely the winner, and it's obviously the best letter to start a name with. Yeah. 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 And then we can create a design, like a personal SnapCon design that we could embroider tomorrow by using that. So I prepared the script before, and this is just, I'm writing SnapCon, and then I'm adding, oh, wait, I need to set the distribution first, sorry. Whoop. And then I can just add, this is our distribution, and this is our very own SnapCon TurtleStitch logo, and only we know it, so if you want it, I can embroider it tomorrow in the TurtleStitch Beginners Workshop for you. Okay, thanks.
Hi, I'm Gordon Stein, and I'm here to present BloxBuddy, our AI tutor for NetsBlocks. We've run a lot of classes with NetsBlocks in the past, and we've noticed that students, I mean, we all know students will outnumber instructors in any classroom, and we can't be everywhere at once, and there will be just a rash of questions that will break out, and we need to run around helping everybody, and it's fun, but it's a lot of work for us, and it would be great if we could get some help. And AI assistants are the hot new thing. I heard there was a talk earlier that unfortunately was too early for my time zone to attend, but it seems it's a popular idea. Great minds thinking alike here. So we're making one focused on educational use in NetsBlocks. So one thing we wanted to avoid is giving away the answers. If you go to ChatGPT and say, make this, it'll just make it for you. It won't try to help you learn it necessarily. It will go straight to building it for you. Although for Snap, we've noticed that a lot of the off-the-shelf AI models are not very good at understanding it, even after we if we give them an image or we try to describe our code, they struggle somewhat with the Snap interface, somewhat from a lack of knowledge, and somewhat from it just being a format they don't understand. So we're creating an AI assistant designed to address these issues. We have a series of prompts that are accessible through this that allow students to get unstuck. So if they're having a difficulty iterating on their project, what do I do next? They can click a button and their project will be interpreted and it will output some ideas for them to work on. Or if they have a bug, it will walk them through trying to fix it. And again, our goal is to assist them. We specifically avoid outputting actual code or editing things in the interface for them, because our goal is for the students to learn to code, not to learn to ask for a completed project. We also focus on structured guidance. So we have continuations for the conversation provided by the AI model, which will allow the student to stay on track. They don't have the ability to wander off into some totally different topic. It stays focused on just their project. And at a certain point, it can cut the conversation off if it feels it's done. Using blocks to code, we're able to give it the ability to actually read the code for the whole project, including custom blocks. And it has retrieval augmented generation using NetsBlocks documentation, which helps with some of our specialized features, which is one of our biggest issues because it hallucinated those. It just made up features, and unfortunately, that's very bad for this use case. So I'd like to give a quick demo. All right, so first demo, I've made a very quick, just a small little project. And I can ask you to explain the code. And in a second, it should pop up with an explanation. This is just a small sample project, but Of course, it's having some stage fright here. Here you go. So it just describes that, when you click the green flag, it goes to center. When you hit space, it goes up. And it offers some things you can ask. How can I make it move in other ways? How do I add another sprite? And we have also, what can I add to it? What should I do next? Can you help me with a bug? The debugging part is exciting, although it's also the most difficult. Here we have a map program, and I've switched it so, oops, everything uses longitude, even though it should be changing latitude. If I ask it to help with this bug, and this is a process we want to improve on debugging, having it be more iterative, be more deductive, and work with the user in try this, and see what we can get it to do from that context. All right. Usually it's a little faster than this. I think my internet's a bit slow today. But in a second, it should pop up with an explanation that these two were set to the wrong variable. And here it says you're setting the long variable when you should be setting the lat variable instead. So this is something we've been working on. So we want to continue working on debugging. We want to work on detecting when students need this help. And we're still iterating on this project. If you'd like to help us test it out, send me an email at gordon.stein@vanderbilt.edu. Thank you for your time.